Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts project at thunderbolts.info. The current standard cosmological model tells us that roughly 96% of the universe is composed of strange, invisible dark stuff. About 73% of the total mass and energy in the universe is said to be composed of so-called dark energy. The concept of dark energy was invented in the 1990s, when scientists studying Type 1a supernovae discovered that the supernovae appeared to be accelerating faster the farther away they were from the observer. Today, cosmologists say that the mysterious force of dark energy is responsible for accelerating the expansion of the universe since the hypothetical Big Bang explosion, although they admit they have no understanding of what dark energy is, nor how it really works. But a new scientific study has only made dark energy more mysterious. Scientists attempting to measure the so-called cosmic expansion rate have discovered that the universe again appears to be expanding much too quickly, even taking into account the invention of dark energy's influence. The study leader states in a recent Scientific American article, the bottom line is that the universe looks like it's expanding about 8% faster than you would have expected based on how it looked in its youth and how we expect it to evolve. We have to take this pretty darn seriously. Charles Bennett of Johns Hopkins University also stated, basically, is there something going on in cosmology that we don't understand? Or is there something going on with the data? One of those is a lot more exciting, but I think the other may be more likely. The Scientific American article offers the following analysis. One of the most exciting possibilities is that dark energy is even stranger than the leading theory suggests. However, as Wal Thornhill explains, the standard cosmology's increasingly strange interpretations become unnecessary in an electric universe.
It's no surprise that Big Bang theorists are having difficulties with each new discovery about the universe. The most recent problem was highlighted in Nature on April 11th. The most precise measurement ever made of the current rate of expansion of the universe has produced a value that appears incompatible with measurements of radiation left over from the Big Bang. If the findings are confirmed by independent techniques, the laws of cosmology might have to be rewritten. The rate of expansion of the universe is supposed to be due to the competing action of dark matter with dark energy. Dark matter's gravity tends to slow cosmic expansion, while dark energy pushes outward and makes it accelerate. It was thought that dark energy's strength has been constant. Now it has been found the rate of expansion is 8% faster than that predicted, based on the cosmic microwave background radiation data. But it is not the man-made laws of cosmology that need to be rewritten. It is the entire set of concepts that underpin Big Bang cosmology. It's no use making up laws about things that don't exist, like dark matter and dark energy. It is simply assumed because of the belief in the Big Bang that the cosmic microwave radiation is from the background rather than the foreground. However, the evidence of asymmetry in that radiation suggests it is locally produced. More to the point, plasma cosmology and the electric universe requires and simply explains the cosmic radiation as being due to microwave radiation from the filamentary galactic electric currents flowing in the neighbourhood of the Sun. Indeed, some of the expected structures, a galaxy-wide sample of dense filamentary structures correlated with spiral arms and star formation, have been recently mapped. See here an example of a network of galactic filaments. Note the roughly orthogonal branching of tributaries, which is characteristic of an electrical discharge, and then compare it with the experimental discharge filaments shown here. In October 2011, I wrote a Nobel Prize for the Dark Side about the prize in physics being awarded to 3 astrophysicists for the accelerating universe. Dark energy is supposed to make up 73% of the universe. The evidence interpreted in this weird way comes from comparing the redshift distances of galaxies with the brightness of their supernovae Type 1a, used as a standard candle. It was found that the supernovae in highly redshifted galaxies are fainter than expected, indicating that they are further away than previously estimated. This, in turn, implied a startling accelerating expansion of the universe, according to the Big Bang model. It's like throwing a ball into the air and having it accelerate upwards. So, a mysterious dark energy was invented, which fills the vacuum and works against gravity. The popular science fiction author Douglas Adams' infinite improbability generator type of argument was called upon to produce this vacuum energy. The language defining vacuum energy is revealing. Vacuum energy is an underlying background energy that exists in space even when the space is devoid of matter, that is, free space. The concept of vacuum energy has been deduced from the concept of virtual particles, which is itself derived from the energy-time uncertainty principle. You may notice the absurdity of the concept, given that the vacuum contains no matter, background or otherwise, yet it is supposed to contain energy. This is impossible. Incredibly, energy has no definition in physics, merely different examples. Douglas Adams was parodying Heisenberg's uncertainty principle of quantum mechanics. Quantum mechanics is merely a probabilistic description of what happens at the scale of subatomic particles, with no real physical understanding of cause and effect. Heisenberg was uncertain because he didn't know, in a physical sense, what he was talking about. He was being truthful, though, when he wrote, "We still lack some essential feature in our image of the structure of matter." The concept of virtual particles winking in and out of existence defies the first principle of physics: thou shalt not magically materialize nor dematerialize matter. Calling matter virtual merely underscores its non-reality. Indeed, the discovery of the acceleration of the expanding universe is an interpretation based on total ignorance of the real nature of stars and the standard candle, the supernova type 1a. A supernova type 1a is supposed to be due to a hypothetical series of incredible events resulting in an exploding white dwarf star. But in an electric universe, a supernova is simply an electrical explosion of a star that draws its energy from a galactic circuit. The remarkable brilliance of a supernova, which can exceed that of its host galaxy for days or weeks, is explained by a kind of power transmission line failure that can also be seen occasionally on Earth. If such a circuit is suddenly opened, the electromagnetic energy stored in the circuit is focused at the point where the circuit is broken, producing catastrophic arcing. Stars too can suddenly have the current focused on them switched off by a plasma instability, causing it to be magnetically pinched off. The result is what's known as an exploding double layer, which results in ejection of matter from the body of the star. This turning inside out of a supernova has been observed, to the puzzlement of theorists. The standard candle of the supernova and its light curve are then simply due to the circuit parameters of galactic transmission lines, which power all stars. What of the discovery of fainter and more short-lived supernovae in high redshift galaxies? The astronomer Halton Arp showed from numerous observations that faint, highly redshifted objects, like quasars, are intrinsically faint because of their youth and not their distance. There was no Big Bang. He proved that quasars are born episodically from the nucleus of active galaxies. Their light is initially faint and highly redshifted as they move rapidly along the spin axis away from their parent. As they mature, they grow brighter and their redshift decreases while they slow down, as the matter within them increases in mass. Finally, the quasars evolve into companion galaxies. The decreasing quasar redshift occurs in discrete steps, which points to a process whereby protons and electrons go through a number of small, quantized, that is resonant, increases in mass as the electrical polarization within the quasar increases. The charge required comes via an electrical umbilical cord in the form of the observed parent galaxy's axial jet. Based on Arp's discovery and the electrical model of galaxies and stars, both stars and supernovae type 1a are naturally dimmer, and the supernovae more short-lived in high redshift galaxies than in low redshift galaxies because of the lower galactic energy density. The Big Bang laws of cosmology need to be discarded, not rewritten. They don't work. All is darkness in the Big Bang universe with its black holes, dark matter and dark energy. The electric universe throws a new light on the subject because its laws of cosmology are simply those of electromagnetism with, for the very first time, definitions of mass and energy in terms of the electrical structure of matter. Of course, I don't expect a Nobel Prize for this sensible explanation. Otherwise, I could meet the fate of the hapless student who created the infinite improbability generator in Douglas Adams' wonderful Hitchhiker's Guide to the Galaxy, when just after he was awarded the Galactic Institute's prize for extreme cleverness, he got lynched by a rampaging mob of respectable physicists who had finally realised that the one thing they really couldn't stand was a smartass.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.